In the figure below, what is the length of RS? Know that the figure isn't drawn to scale. So when I look at this figure, I have to remember that it's not drawn to scale, and that just because something looks like it's similar, I can't assume that it is. So I know that I want to find the length of RS, and looking at my figure, the only information that I get is the information that they give me. I can see that I have a side length here, RU is 6 units, UT is 8 units, and the side ST is 5 units. But I'm interested in finding the side RS. And in order to do that, I have to look at the relationships here. I see that I have two 90-degree angles. I don't know that angle R is the same as angle T, but I'm going to use the information here to find RS, or the length of line segment RS. First, I'm going to draw a line segment. I'm just going to add to the picture to help me solve the problem. Now that I've drawn this line connecting the vertex R to vertex T, I have a right triangle. And what do I remember about right triangles? Oh yeah, that's right, Pythagorean theorem. Because I know two side lengths. I know the 6 and the 8. So on this side, I'm just going to write Pythag a squared plus b squared equals c squared. So when I'm looking at my picture, here's my right angle. And there's my hypotenuse. So when I label my sides of the right triangle, here's my A, B, and C. So now I can plug in to my formula. So I said my A was 6, and my B is 8, and my C, I don't know. That's that line segment that I drew between vertex R and vertex T. So that is still unknown. So C is just going to remain C. Alright, so now I have now I have something that I can work with. I have 6 squared plus 8 squared equals C squared. So now I can just simplify this. 6 squared is 36. 8 squared, or 8 times 8, is 64. And C squared, just going to bring that on down. Now I can do a little addition. 64 plus 36 gives me 100 equals C squared. Now I'm down to what C squared is, but I want to know what C is. Okay, so I've gone through a couple of steps. Got 100 equals C squared. So now I need to take the square root of both sides. Great, and I know that 10 equals C. Great. So that's only half of the problem. Now I know that the distance from the vertex R to the vertex T is 10 units. So I'm going to write 10 so that I know this distance. Okay, now looking at my image, or this figure, looking at RUT, I was able to form a right triangle. And I also have a right triangle looking at RSU. The 90-degree angle is at this vertex S, or this angle. And again, I can use Pythagorean theorem because I know two of the sides. I know 10 and 5. So now I need to find this missing side. I'm going to label my triangle. Here's an A, here's a B, and again here's my C because it's the opposite side of my 90-degree angle. So now I need to do a little bit of scratch work again so that I can find my A, which represents the distance from RS, which is line segment RS. Okay, great. So remember we said